Okay, so what are the three prime benefits of using PCA, Principal Component Analysis? We will discuss first about Principal Component Analysis, and then we would spend time discussing about SVD. Yeah, we'll get to that later. So the first prime benefit of Principal Component Analysis is to reduce the number of columns. Say you have 200 plus columns, reducing it to 10 plus, which is meaningful. Reduction is made possible through mathematical transformations, not through deletions at all. For example, this column would contain the information contained in all of these columns. The second column also would contain the information contained in all the columns. We'll get to the finer nuances of that in a moment from now. We also need to identify the relationship between various columns. We will see on how to establish a relationship between the various columns. How to effectively name a column, right? And the third benefit is visualize the multidimensional data in two-dimensional space. We know for a fact that humanly it is only possible to visualize maximum 3 dimensions, not more than that. 1 dimension, 2 dimensions. At most, in the world that we are living in, we can visualize only this. If there's a 4th dimension which is introduced, you cannot visualize by drawing that on this 2-dimensional space. That would not be possible. But thanks to PCA, even if you have 200 such variables, 200 different axes, 200 such dimensions, we will be able to visualize. How is that possible? We'll look into that in the subsequent slides. Okay, look at this. We would be using this university data set. These are all your university names. And for each university, there is average SAT score, which is a written exam, competitive exam. More the number of marks that you get, better are your chances to get admitted into any B school, right? Top 10. Students who applied to this, for example, Brown University, 89% of the students who have applied were in top 10 ranking when it comes to their intermediate or school days, plus 2, etc. Out of 100 applications, 22 people get admitted to Brown University. That is what is your acceptance ratio. Student faculty ratio is 13. That is, for every 13 students, there is a professor. This is expense in dollars and this is a graduation rate. You have the data. We are taking a tiny example just to understand the intuition of Principal Component Analysis. But normally we apply dimension reduction techniques such as Principal Component Analysis when there are huge number of variables. Okay. Mathematically, your Principal Component 1 is calculated using all these values. Using all these values, mathematically, this value gets calculated. Of course, if you use the raw data as is, if you use this raw data as is, you would be in a position to get 100% of information. No doubt about that. You'd get 100% of information if you use all these data points. However, the single principal component, which is mathematically transformed now, may not capture 100% of information, and most likely than not, it would not. Probably it would capture 75% of information. And mathematically using all these 6 data points, Principal Component 2 is calculated. Maybe this principal component 2 would capture, say, 20% of information. Using all these, yet another mathematical calculation happens and you get a third value. Probably this would capture 2% of information, so on and so forth. But when you look into all of these principal components put together, it would capture once again 100% of information. But we would never use all the principal components, because the moment you use all the principal components, it is as good as using your original data set. Okay. The hope, logic, and understanding here is, let me erase this just a moment here. The hope, logic, and understanding here is that rather than use this raw data which has 6 variables, yeah, can we use the top 2 or 3 principal components which would probably capture, say, 90% of information or 95% of information. If the first principal component, say, captures 75% of information and the second principal component, say, it captures 10%, say another 5% is captured by the third principal component. These 3 put together would account to 90% of information. So here is where we need to do cost-benefit analysis. If you use all the 6 variables, of course, your accuracy of whatever you're trying to do increases. But at the same time, your performance decreases. Instead, can I get my job done using only the first 3 principal components? Rather than 6 variables, I'm only using 3 variables, right? And if you use only these 3 variables, accuracy would decrease, but the performance would increase. So this is driven using your business decision. Okay. And one more good part here is, if there are any missing values here, say there is NA here, say there is NA here, these are all missing values. If there is no value, system would automatically replace that missing value with NA. If you have NA here, when you deal with this column, or when you deal with this data to build your prediction models, wherever you have NA, the entire row would be deleted. Say you're trying to do some prediction. You're trying to predict on what will be the salaries of students given all these 6 input variables. Say that is what you're trying to achieve here. When you try to build a regression model, Georgetown, Johns Hopkins, and Northwestern University, these 3 records or rows would get deleted. Why? Because you have NA values. Even if you have NA in one place, the entire record would be ignored, deleted from your prediction model or analysis. So you're losing out 3 critical records. Instead, if you do a principal component analysis, you would get a corresponding principal component value using all these values. The only thing is this NA value would be ignored, that's it. But still you have the SAT score, you have top 10, you have acceptance ratio, expenses, and graduation rate. We use all of these and mathematically calculate another value here, which will not have your missing value. There won't be any NA here. Right? That's another application of your PCA. So as I've already told you all, the idea is not to delete columns or select columns, but idea here is to mathematically do some computation whereby we capture the information captured by the 6 variables in the initial few principal components. That's your analysis here, or the basic intuition. Now let us look into a very toy example and try to understand the PCA intuition.